All right, today we're going to dig into a pretty fascinating scientific paper. It's one that puts a question mark on one of the longest-running data sets in all of science. I'm talking about a record that goes back over 400 years.
So for 4 centuries, think about that. We've been tracking the sun's activity, almost like taking its pulse. And this record? It's the foundation for so much of what we know about solar cycles and space weather. But what if that record has a serious flaw?
Okay, so to really get into this mystery, we've got to meet the main character of our story. It's called the Sunspot Number. And it's this simple but incredibly powerful tool that's basically been the backbone of solar science for, well, forever. So what is it exactly? Well, the Sunspot Number is just a standardized way to count sunspots. And since sunspots are these areas of super intense magnetic fields, counting them gives us a pretty direct window into what the sun's magnetic engine is up to.
But here's what makes this number so special. It's history. We're talking more than 400 years of data. That is incredible. It's easily one of the most analyzed chunks of data in all of science. You know, right up there with things like stock market trends.
Now we have to remember, it is what we call a proxy. It's not a direct measurement, it's an indirect one. But man, is it a useful one. It lets us look way back in time, long before we had all the fancy satellites and instruments we have today.
Okay, so in any good detective story, you can't just rely on one piece of evidence, right? You need to call in some expert witnesses to see if the stories line up. And in our case, our witnesses are going to be some very modern, very high-tech instruments.
You know, this is really the bedrock of science. You don't just trust, you verify. So if that old sunspot number is as accurate as we think, it should line up perfectly with what our modern tools are telling us. So let's bring our first witness to the stand.
Okay, now take a look at this. It might seem like a complicated chart, but the story here is actually super simple. You see those lines? We've got microwave emissions from the sun, and we've got direct measurements of the sun's magnetic field from space. And just look at how they move together. They are in perfect lockstep. They're telling the exact same story about what the sun is doing. And just to be absolutely sure, we've got another witness. This is a totally different measurement called the magnesium-2 index. And look at that. Again, the red line, that's our magnetic field data, and the blue line from the magnesium index is tracing it almost perfectly. The verdict is coming in loud and clear. Our modern data is consistent and totally reliable.
So this is the really crucial point. All of our modern independent instruments, the ones measuring microwaves, magnetic fields, ultraviolet radiation, they are all singing the same tune. They're in total agreement. This gives us a rock-solid, verified baseline of what the sun is actually doing. And this is where our little detective story takes a really dramatic turn. We have our trusted 400-year-old record on one side, and on the other, we have our verified modern witnesses. So what happens when you put them in the same room, face to face?
This really is the moment of truth. Do their stories match? Does that old historical proxy line up with the direct modern measurements?
And here we go. Take a close look at this. The red line, that's the magnetic data from HMI. That's our verified truth, remember? And the blue line is the official sunspot number. For years, they just track each other beautifully. But then, look inside that shaded box. For about 18 months, from mid-2014 to the end of 2015, the blue line just drops away. A gap appears. A gap that really shouldn't be there.
Let's just pause on that for a second. Outside of that 18-month window, the two datasets are basically best friends. But during that specific period, something goes haywire. The sunspot number starts telling a completely different story from every single one of our other modern instruments.
So now we've got ourselves a real mystery, an 18-month-long anomaly in a 400-year-old data set. What's the next step in any investigation? You gotta look for clues. You gotta ask what was happening during that exact time.
Something must have changed in that year and a half. So let's start digging through the procedural records, how the data was actually collected, and see if we can find anything.
And boom, here it is. This could be our smoking gun. What you're looking at here is a chart of how many raw sunspot observations were sent in by observers each year. Now look what happens right in our interval of interest. The number of reports just skyrockets. It nearly doubles in a really short amount of time. And this huge change in how the data was being gathered lines up exactly with the anomaly we saw on the other chart.
So we have a prime suspect, right? A sudden, massive change in how the data was collected. But here's the thing. We can't definitively prove it. And the reason why we can't solve this case, well, it turns this little scientific puzzle into a much bigger lesson about transparency in science.
I mean, the next step seems pretty obvious, doesn't it? Let's just go look at the raw data. Let's check the individual reports from all those new observers and figure out what caused the numbers to go off track.
And here, we hit a brick wall. This is the real heart of the problem. For centuries, this kind of raw data was public. Anyone could look at it. But since 2011, it hasn't been. So without access to those individual observations, researchers simply can't investigate what happened. It's like the evidence is locked in a room and nobody has the key. And this isn't just one person's opinion, by the way. This quote here from another paper really gets to the core issue. It says that when source data is inaccessible, it stops the entire scientific community from being able to verify, analyze, and ultimately improve these incredibly important records.
So let's just recap our whole investigation here. We started with this historic 400-year-old record. We found a potential pretty serious flaw. Our modern witnesses, all those fancy satellites and instruments, they all confirm this weird 18-month anomaly. We even found a potential smoking gun, a huge sudden surge in the number of raw observations. But the one thing we need to solve the case, the raw data itself, is locked away. It's a powerful, powerful reminder of just how crucial open, transparent data is for science to work.
And all of this leaves us with one last big question. When the integrity of a cornerstone of solar science is on the line, when the clues to solving the mystery are right there, should the door to that data ever be locked?